All right, welcome everyone. I'm SVA, and I want to tell you about Pretty Easy Privacy, a project that stands at the very beginning at the moment of rolling out mass encryption by default for everyone. You might have guessed that the name comes from PGP, Pretty Good Privacy. So who knows about PGP? Great. Who's using it? Who's using it daily? All right. So you see, we really need to get this like pretty easy. So I start my talk with an intro where I also introduce myself. Then a general thing about the concept, which is a rather long chapter. Then a brief note about the organization. And then going deeper into tech. And then showing you the current implementations and giving some demos on the apps. So first of all, this quote from Snowden: "I don't want to live in a world where everything I say, everything I do, everyone I talk to, every expression of creativity or love or friendship is recorded." So I agree, but the problem is that we actually live in such a world now. So everything we do is recorded. Not only because of the UK and the US, there's also stuff happening in India. The central monitoring system started in 2013, and we still don't know where what data goes and what they actually do with it, who has access and all these things. So yeah, we have a problem that online communication is visible like a postcard, and that this world has mass surveillance. So the solution we're trying to do is to create mass encryption. And second, then we're trying to have mass anonymization. So yeah, just a starting point. We see ourselves as cypherpunks, and we want to optimize the costs of mass surveillance because it is there. We cannot stop it anymore. So we created Pretty Easy Privacy, not only for privacy for citizens, but also security for companies. That's the reason why you guys are here mainly. So yeah, and that's me. I'm coming from the humanities, computer science as a side course. I'm done a lot of cryptoparties in India, founder of cryptoparty.in, founder of Hillhacks and Hackbeach. Please check it out. Hillhacks happening in May here in India, in the mountains. My name's SVA. I'm trying to use it as a unique addressing in the internet. If you want to know my legal name, you can check out the board members of the Chaos Computer Club or the Hackers Without Borders. And see, the only female name there is going to be mine. And I'm also affiliated with the Renewable Freedom Foundation and the PEP Foundation, which I'm here for. So, concept overview: privacy by default, pretty easy privacy, peer-to-peer and end-to-end, free software, compatibility, and anonymity. So that's the 6 points I want to go through with you now. So the first one is privacy by default. So PEP does what the user would want to do. And if every one of you might have already taught GPG to people, so then we can even say what they should do, right? And then they do mistakes and it's not working. So we're coming from this, crypto teaching background. So at one point we just said, instead of writing how-to guides, why don't we just write the user expectations into software and standards? So let's just write protocols and software which is actually using the protocol. Another part of the concept is the pretty easy privacy by default. So it's easy to install, easy to understand, easy to use. You have no hassle and there's no training needed. And also it'll be easy, or it is easy, or it will be once we have a proper documentation for app developers as well. I explained that in the chapter of tech. So one part where we make it easy is the fingerprints. So we're translating those usually hexadecimal-based fingerprints into so-called trust words. So instead of EC5539C8FECF, you just say battery horse staple. So then you can read it out loud on the phone, very convenient, and I mean, you all know this. This is, by the way, one piece where we cannot put it into software or protocol, because establishing trust can only be done by the user itself. So they can stay without, they can use encryption without checking the fingerprints, and I guess we all have done this, that we used OTR without actually verifying the fingerprints, so that's fine. But to actually then establish trust, you have to still do it. So that's the last hassle which is left for the user. So another part where we're trying to make it easy is we want to sync keys on multiple devices, which so far is still an unsolved problem out there. We have solved it. It's not there yet in the version out there. It'll be there in the next, the version 2.0. It's already in testing. So we realized this with the help of device groups. So if you have a new device, it generates a device key, pings with that key in the device group. Then the existing devices and the user will verify the new device. And then all the devices agree on a secret main group key and exchange their secret keys to do so. So you can also sync contacts and calendar that way. And we also finally have solved the problem of backups. So also the user doesn't have the hassle of backups anymore. As soon as there's more than one device and you lose one, you still have one left, unless your house burns down and all your devices are lost, but then you have more problems than that. So yeah, here again, you have the PEP, then you check the fingerprints, you make the trust, the handshake, and then both devices are in the group. So this is how it looks like in the real screen. So there's a phone and an Outlook, and they're just comparing the fingerprints, and then you click the trust button, and then they're all part of the group. So this is hopefully also making it very easy. Then another point in the concept is the peer-to-peer end-to-end. No centralized infrastructure or closed services. This is when you want to do crypto right, it's the only way you can do it. I mean, you can do crypto right, like Signal's doing, and then having a closed service. So only your friends who are actually installing it, you can talk to them. So this mistake we're also not trying to do. We're not trying to create yet another crypto app here. And I'm coming to this, we're providing an engine which can be plugged into existing apps. So that, yeah, there will be encryption by default everywhere. A next point in this line you have to tick is to have it free software. If you want to have trustworthy crypto, it can only be trustworthy if it's open source and everyone can have a look at it. We also have audits ongoing. There's the first audit of the engine has already been published some months back. And then part of the concept is the compatibility. So we, as I said, we don't want to create yet another crypto app with a closed user base and centralized services or whatnot. So we want to support multiple crypto technologies, multiple message transports, multiple platforms, and multiple languages. So this is, for example, the crypto. The bolded part is the one the engine can already speak at this moment. The rest is the stuff that is planned. Whatever will be relevant will be included there at one point. And this is the transport. So at the moment, we only started with email because it's still the mainly the widely used transport protocol out there in the internet, besides HTTP, but that we already solved with HTTPS. And we're also trying to get into the non-open standards. So some of them are anyway XMPP based, and the others we need to see, plugging it into a Twitter client to have the direct messages encrypted. That'll be easy, but plugging it into WhatsApp will be more difficult. Let's see how we get this going. And we even want to go down to SMS and all that stuff. And the last part of the concept is anonymity. So now I've been talking about encryption, and actually what we do at the moment is not privacy by default, but encryption by default. Because with encryption, you have the content private, but not the environment. So the metadata is still visible. In an email, you see the from, you see the to, you see the IPs you've been sending from, you have the subject, you have the size of the email. That's all still visible if you have it encrypted. So we need to somehow get rid of this metadata. So we started with like an obvious thing to just put the subject inline. So the clients then, like the PEP clients are showing it just in the subject line. And if a non-PEP user gets such an email, then it's just the first line of the body is saying subject, column, subject. And the subject's going to be replaced by encrypted or something, as you might do with encrypted emails anyway nowadays. And then the next version will also obfuscate and encrypt the rest of the header, whatever is possible. Like you can obfuscate the user agent and just randomly choose any and stuff like that. So, but yeah, that's not all of it. So we want to pipe it through GNU-net in the far future. GNU-net is a project started in academia in 2002 with the first white paper. So they're working on this, writing PhD theses and all that. So to explain what it's about, I have this example. So in the 70s and the 80s, the internet started with the version 1, and everyone was like, wow, I can access your computer and you can check out mine. How awesome is that, right? So everyone was really excited. We could connect computers to each other and access other computers. But nowadays, we have the version 1.1 where we just say, yeah, sure, I can access other computers and use their services. But wait, what? They can also access mine? That's actually, when I did a crypto party, one of my very first lines of, like, you need to be aware that if you are connected to the internet, that the internet is also connected to you. And this is something which GNU-net's trying to solve with end-to-end encryption and anonymization of the way data flows. So their tagline is, you broke the internet, let's make a GNU one. I really like it. I just read the quote. GNU-net is a mesh routing layer for end-to-end encrypted networking and a framework for distributed applications designed to replace the old insecure internet protocol stack. So what they're actually doing is they rewrite TCP/IP and stack a bunch of other protocol layers on it. And they already done this. It's like working in like testing environment. And yeah, as I said, it's academia. So let's see how it actually gets when it gets going. So as a summary for the concept, the idea is that the users don't have to think about the crypto anymore. They can just use it by default. And there was this journalist writing this, what I quoted down there. It is this little hacker inside that decides on the cryptography chosen to communicate with the message recipient. So it's actually what we do nowadays. Like you start a query in IRC and then you're like, oh, you don't do OTR in IRC? Let's move over to Jabber. So then you meet each other in Jabber and then you're like, oh, you're also using conversations, so let's use Omemo. So that's something we do on a daily basis. We just decide what crypto technology we are using right and now, because we are techies and we are just used to do that. So, but we cannot expect all the people out there, and especially not our grandmothers, to actually decide if they want to use OTR and Jabber now or Omemo, or rather want to switch to Signal. So we just want to have this decision been taken by the software. So whatever crypto technology is there with the communication partner will be just chosen by the software. So now the brief overview on the organization. So we have a company which sells applications and services, and we have a foundation which is supporting free software and which is the owner of the code. That's very important. So the code always stays free, even if the company gets whatever sold by things. The engine and the adapters will always be free. And yeah, we're trying to be a sustainable open source project. So we also created a business model, and we're already selling an Outlook plugin on 2 companies, and they're already using it. So I hope it'll work out. So now to the tech part. So I'll explain a bit on the architecture with the engine and the adapters, already briefly mentioned. I show you a list of repos and developing platforms, and then some more details of the engine. So here's the architecture. So on top, you have the actual application layer, which is a plugin or an app. In the example of Outlook, it's the Outlook add-on, which you can install into Outlook. Then you have adapters, which in the example of Outlook is a COM server adapter, and we have like Python adapters and JSON adapters and whatnot. So we have various adapters to plug in the engine. The engine is just one, and the engine serves the crypto. It's an API. It makes the fully automated key management functions, and the engine knows all the transport protocols. So that's also the idea of making it pretty easy for the developer, because the developer only needs to make the interface between the app and the adapter. And if there's any new crypto technology showing up, or if there's anything that breaks, we take care of fixing this in the engine. And you can just have a look at the code audit and trust us. So yeah, that's the URLs to get some more on the architecture. This is a more detailed view. So there's again the Outlook with the plugin, the COM server adapter, and it also uses some JSON. Then Thunderbird, for example, yeah, you see it. Thunderbird is for all platforms. So Thunderbird has this plugin called Enigmail, which is doing the crypto. And then it uses, again, the JSON adapter and then all those specific parts for the actual platform. And yeah, so then OS X is pretty straight as usual. And there's the example of KDE as well. So this is a list of adapters and repos. So you see there's a Java adapter, JSON, Python, Qt, iOS, and yeah, we're just trying to cover most of the common languages. And with that URL, you find the source code. You also find it if you click on pep.foundation website and click on source code. And yeah, with the URLs, you can already see where we're coming from. Who knows about CSRD? Yeah, it's very uncommon in India. It's such a pity. You should check it out. That's the platforms we're developing on: iOS, Android, Linux, BSD, macOS, Windows. That's like everything. And here we have the engine. So here we take care of the crypto tech services, the messaging functions, and the transport protocols. So the crypto includes at this point support of S/MIME, PGP, and then CMS, which is a cryptographic message syntax, and will do all the rest at one point. Same for transports. At the moment it's email, and it will do then all the rest. It serves this, yeah, key management services, and in the future it then also serves for the anonymization. All right. Current applications. We have Android, Outlook, Thunderbird coming very soon, and like a roadmap, what's happening after. And again, we're at the very beginning, so having those apps is more or less a proof of concept. And we would like to have other developers than just plugging it in once they see that it actually works and once we have proper documentation. So the current implementation handles OpenGPG and S/MIME without any hassle for the user. So it automatically encrypts. It encrypts the subject inline. There's no key management needed. There's no key server or other centralized services infrastructure. The fingerprints are translated into trust words. You have an opt-in passphrase for keys. So by default, your GPG key won't be having any passphrase. I know that most of you are like now, oh my God, but think about your grandmother. So she wouldn't be wanting to type in a password, not even after rebooting only. So as we want to have it pretty easy, by default, there's no password. And then in the next version, header encrypted and obfuscated, and the sync protocol will be there. So yeah, there's this Android K9 fork. K9 is an email client. It's available on Play Store and on F-Droid. There is Outlook for Windows. It's available on prettyeasyprivacy.com. It's free as in freedom, but not as in free beer. So if you want to test it out, you can just contact us for a testing license. And pretty excited, we have a Hindi version now. So some of the folks got, what's the word, motivated of translating the Outlook plugin to Hindi now. So this has just been recently added in the repository. Then there's Thunderbird Enigmail, which will be coming with the next release of Enigmail in, let's say, the next couple of months. Then you don't have the need for users to manage keys anymore, but you can still switch to the advanced expert mode, which is then the old mode as it is right now. And this is really exciting because if I think on the crypto parties or the crypto teachings, you usually have like at least 1 hour, better 2, planned for GPG. So with this thing, it's going to be hopefully as easy as installing the Tor browser, which you planned usually like 15 minutes. You planned actually more time to explain what Tor is about, but the install is just click, install, done, you can use it. So then the slide of the upcoming stuff. So yeah, Thunderbirds is the next, then contact, that's Kmail from KDE, and then we are well aware that we need to have browser plugins, even though as we as geeks don't like it too much to tell the people to use webmail and browser plugins, but that's the reality out there. So we need to do that. And at the bottom, you find all the paid services. So it's also very much focused on big environments and companies. So you have all this MDM, Microsoft Windows, blah thing. Then the demos now. So I'll first give an intro of the use case, and then I show that in Android and Outlook. So that's the use case. We have 2 users installing PEP. And then they send an email, like a postcard, unencrypted, where the key is attached. Then the next message is the so-called yellow mode, where you have where you are already encrypted, but you haven't checked the fingerprints. So the next step is then to actually verify the trust words on a phone or any other trusted line. You make the handshake, and then you are in this green mode, the encrypted line. So this again is a diagram. So you start with the postcard, then you put it into the envelope, which is still kind of open. You check the trust words, and then you are in this green secure mode. So this is how it looks like in Android. It's the normal K9 look and feel. You need version 4.3 or higher, get it Play Store and F-Droid. So installing, installed. That's the welcome screen after the fresh install. So you set up the account. The keys will now be generated automatically. If you want to import existing keys, at the moment you need a workaround because the sync protocol is going to solve that problem. So we didn't solve it in that version too much. There's a workaround for that. So you choose the account type. We'll choose IMAP here, and you type in the server settings, SMTP server settings, account name, and you're done. So this is the compose view in the gray mode, which is unencrypted, plain text, and the key will be attached now automatically. You don't have to do this. So you got a reply from your partner, which doesn't have to be a PEP user, by the way. It just needs to be a PGP user who's attaching the key. So, but we played the example with the PEP user though. But if the other user is using PGP just normal and attaching the key just as an attachment, it will also serve the very same way. So once you get this email, you click PEP in the upper corner to get the handshake thing done. So you see the trust words, then you can compare the trust words. So the trust words are by default in the language of your system. So if you're now communicating with someone who's having another system language, you go to the menu and choose any of the languages. So far we have all those. So I think most people would be just falling back to English if they have other languages. I mean, we cannot support any new language, I don't know. So now we've chosen Spanish. So now the trust words just gets translated in Spanish. Then you click the confirm trust words. Now I'm also showing how to get the PGP fingerprints, because if you're communicating with a normal PGP user, you need to see the fingerprints. So you go to the menu to choose PGP fingerprints, and then you get the normal fingerprint view. And now you click confirm, and you're on the secure and trusted green mode. So yeah, now you can start emailing, and you can also optionally disable. So there's again a menu, and then you can just also like write and receive emails. So yeah, that was Android, available out there, and this is Outlook. It needs Windows 7 to 10, Outlook 10 to 16. Again, installation screen, accept the license agreement, then you have this Windows thing of giving the permission of having another service installing something, then it's actually installing, installation completed. So that's also part of the concept. I said easy to install, so it shall be less than a minute to actually install it. So then here it depends. If you don't have any GPG for Win installed, it'll be just installing automatically in this folder. If there is already a version of GPG installed which is usable, then we just use it. And if there's an older version of GPG installed, then you get this pop-up asking you if it's fine to update the version and that the old one's going to be stored somewhere. And yeah, so that's the only hassle you have when installing. And for sure, you can also make the silent unintended installation. You just do this command in the console with admin rights. So now you've installed Outlook. And again, you start with an email, sending out an email, which is now in the unsecure gray mode. You get the reply back. So now you're in the secure yellow mode. You confirm the trust words, make the handshake, and you're in the secure and trusted green mode, and you can continue doing so. You can also at any time reconfirm the trust words, in Android for sure as well. So you just click it again, check them, and you can then still choose again to trust or not to trust. And as well, you can disable the whole thing, but still be able to attach the key. So for example, if you have a fresh a person who's not using or who has just installed PEP, you want to send an unencrypted email with the attached key to actually start the handshake process. So yeah, that's with the key attached. Again, that picture of the reality, and that's already it. So any questions? Yeah.
I have a couple of questions. I have a couple of questions. One being that you said this is a framework that you can optionally plug into your own app as well.
Yeah.
So what about something like Signal or open source systems that have centralized infrastructure? For an app, it's fine, you just plug in the code. But when you need infrastructure level changes, isn't that a huge deterrent for adoption?
It is, but if we want to have it, I mean, in Signal, it's already encrypted. So the goal is to have encryption by default. That's the first step. So we can also leave it out, but you can also, if you have once the engine running, then you can also have like a PEP Signal app who's like additionally taking whatever gibberish Signal is pushing out. I mean, we're plugging in at the transport level. So whatever has been transported can again be piped through PEP, which is at the moment not very interesting because we're only doing encryption as well. But once we have the anonymization running, it'll be interesting because then you can use your Signal messages, like use your Signal application, but you can still pipe it through GNU-net that way.
All right, and another just small question, like what if somebody's key changes? How was that handled?
It's been attached all the time. So then you just need to re-import the new key.
And it would go through the same process as you showed here.
Yeah, you just need to make a new handshake, or you stay in the yellow mode. But that's one of the standards we're trying to have then, that everyone's attaching the key. So that's not the case at the moment. So you need then, if my key changes even like all the years back when I haven't thought about the standard, I was then attaching it like the next couple of weeks and just having a sign, like a footer of, oh, by the way, my key changed. I have attached it. So because we definitely need to get rid of the web of trust and the key servers. I think everyone agrees.
Thank you.
A couple of things. One, is there any way that Keybase.io can be plugged into this? Because I agree, the Web of Trust hasn't worked, and I don't think it's going to work. But Keybase I see as an interesting alternative for establishing trust, which kind of gets away from the trust words model and still makes things very easy. So one, is there any way of plugging that in? And two, have you, within corporations, I find that they're much more comfortable using SMIME than PGP, especially because they have various kinds of requirements of being able to get at their employees' email, right, if they leave, etc. So who ends up using the corporate Outlook plugin?
Yeah, so I start with the second question. So key escrow has also been on the roadmap for 2017. At the moment, it is solved that that every email that's been sent by an employee is also been sent in BCC to like employee XY minus key, whatever, and so there's a copy of each conversation in another account. So if the employee leaves, they have a copy of the full communication, but that's only a workaround. So we definitely need to have key escrow. And SMIME is supported. So if a company prefers to use SMIME with Outlook, it's there. But SMIME again has the problem of being a central authority in between, which is not solving the problem in sum. So yeah, that was reply to the second question. And the first one is Keybase.io. I just recently also thought that I should have, again, a look at it. I remember when it started that I looked it up, and I didn't like the concept that you have to bring together all your online IDs at one point. So I'm not the kind of, I know that you're the kind of person who's like liking this and having the convenience and anyway being a public person somehow. But that's not my model, so I actually have no clue how Keybase.io works. But like, ideally it should work because the idea is that it just works anywhere. So, but I have no clue about Keybase.io and the tech behind.
I use Mutt as my email client. Is there anything that is currently?
Our main tech lead is a very heavy Mutt user, and there is the Python adapter been written already for as one of the very first ones, because he was so keen on plugging it into Mutt. But getting out the Outlook and the Android stuff was much more important. But he's always like, yeah, I only need like a week and then I've done this. So I was even thinking of putting it into this coming next thing, because that's more like a marketing slide. So they don't care about Mutt. But I knew there would be Mutt users in here. So yeah, I think it will happen at one point.
Thank you. In your diagram, there was a piece of hardware somewhere. Can you go back to that? What was that?
In the timeline?
I think the timeline, yeah.
Must be here somewhere.
Yeah, the key escrow.
Yeah, that's what he was talking about. That's the method of having, when the employer leaves the company, because we have end-to-end encryption and you cannot break that, because then you break the whole system. But as a company, you still have the requirements of getting into whatever your employee is doing. And even if the person, whatever, leaves by fight or so, and they would not be leaving their passwords, then you have this key escrow. That's, yeah, okay. Yeah, that's why the picture is a hard drive.
So large companies use hardware security modules, which is a piece of hardware that takes care of generating your keys, rotating them frequently and everything. So I think that is what the diagram portrayed.
Yeah, that's why they chosen this hard drive as a picture. Thank you. Any other question? Then I have a question for you, because as I multiple times said, that this is, we are standing at the very beginning, and this is really a long-term plan of rolling out mass encryption. So do you think the plan is, do you see any flaws in that plan? Do you see any mistakes, some stuff we might have overseen it? Or are you convinced now, maybe the other direction, that this would work? Yeah.
Hello. Any model can be mathematically formulated, right? Like that exercise has been done, because that is the best way to see any flaw. Have you used any tools which help these this thing?
No, because we are not implementing any new crypto. We're just using existing crypto. So we don't have to check on any mathematical crypto flaws. But yeah.
Yeah, what I'm telling is one step above that. Let me bring it to very basics. Anything in this world can be modeled. You agree to it? Anything in this world can be mathematically modeled. You agree to this?
No, not on this plan.
Okay. In that case, at least what you are proposing, that can be mathematically modeled.
Okay.
And that will give a very clear idea whether it is having flaw.
Okay. Yeah, I have a close friend who's a very deep mathematician. I ask him, whom we should ask for that.
You asked for such feedback that I thought I will poke this. I thought I will bring this so that you can work it later.
Thank you.
Yeah.
This is a critical piece of software. So what is the plan for source code auditing? If I were to use it, I would like to know if there are any bugs inside.
Yeah, so the first audit of the engine's already been done. So every piece, also the adapters, shall be audited with every new version. So now again, when we have the version 2.0, it'll be just published after the audit has been done, and the audit's also published. So if you go on PEP Foundation and look for the press releases, there's been a press release on the first audit that has been done, and you find the whole report there. And yeah, they found a lot of like buffer overflows and stuff like that. And you're very invited to do your own audit and drop us a message. Yeah, it's all there. So yeah, on pep.foundation, you just click on source, and then you end up in a track where you then find the HG web. And there's also a fisheye from Jira where it's a bit more convenient to browse. But yeah, the websites are not very convenient. I'm sorry for that. But we're glad that we actually came out now with a proof of concept of software. So next thing is also to work on the websites. All right, anything else?
You mentioned that the organization, the business model is meant to sustain the foundation. One of the challenges you have, for example, OpenSSL, it's used everywhere, and when an issue happened, we find out that there's only 2 persons working on it, and when they have time, and now Linux Foundation has stepped in to help, and a lot of organizations as well. So if this becomes a core infrastructure project, do you see at some point this being, collaborating with Linux Foundation to make sure that this is sustainable from a long-term perspective?
Yeah, we're trying. I mean, now we've set it up the way that we can start being like that, and once it gets like a critical, if the plan works out, then we'll definitely, like as a foundation, we are also applying for funds at like other foundations, and at the moment it's all based on the usual investor money. So the foundation got some funds from like private persons, and the company got the usual investments, and so that's also where the code audit's been paid from now. But ideally, all the software which is written and also the code audits and everything will be also paid by the foundation, so that the company is just gaining money and sustaining and pushing the revenue into the foundation, and then the foundation is actually spending the money on these things. But we're definitely not going to do the OpenSSL mistake, or what means mistake? We're all glad that this guy who's developing conversations and actually introduced Omemo, he's also just sitting there and doing writing builds to some company, doing some work, sometimes for paid hours, but most of the times non-paid hours. So I met him recently and I was just happy to pay him a beer, right? But that's also not going to sustain him. And so yeah, we're trying to have this in mind from the very beginning and do whatever we can right now. Okay, any more questions? So I brought stickers, some are here, some in the back. And yeah, I'll be here the rest of the evening, mainly in the water at the beach, most probably. And yeah, happy to talk to you.